Welcome to C001, our very first chemistry lesson. Today we are going to understand one of the most fundamental concepts in all of chemistry, the mole. The mole is the bridge between the invisible world of atoms and the real world of grams and liters that you can measure in a laboratory. Once you understand the mole, almost everything in chemistry starts to make sense. So let us begin. Think about this for a moment. Atoms are incredibly tiny. A single drop of water contains over 1.6 sextillion water molecules. That is a 1 followed by 21 zeros. There is absolutely no way to count atoms one by one. So chemists needed a smarter approach. They needed a counting unit, just like we used the word dozen to mean 12. If I say 1 dozen eggs, you immediately know I mean 12. Chemists invented the mole as their counting unit for atoms and molecules. 1 mole of anything contains exactly 6.022 times 10 to the power of 23 of those particles. It does not matter whether you are counting atoms, molecules, or ions. 1 mole always means the same number of particles. That number has a name, Avogadro's number. Avogadro's number is 6.022 times 10 to the power of 23. Let me help you feel just how enormous this number is. If you had a mole of seconds, that would be about 19 quadrillion years. The entire age of the universe is only 13.8 billion years. So a mole of seconds would be roughly a million times older than the universe itself. If you spread a mole of sand grains across the surface of the Earth, it would cover every continent and every ocean to a depth of several kilometers. This number is so large because atoms are so incredibly small. But here is the most practical fact for chemistry: 1 mole of any gas at standard temperature and pressure occupies exactly 22.4 liters. This is called the molar volume, and you will use it constantly in gas problems. The molar mass of a substance is simply the mass of 1 mole of it, expressed in grams per mole. The beautiful thing is that the molar mass of any element numerically equals its atomic mass from the periodic table. Carbon has an atomic mass of 12, so its molar mass is 12 grams per mole. Oxygen has atomic mass 16, so its molar mass is 16 grams per mole. For compounds, you just add up the molar masses of all the atoms. Water is H2O, so it is 2 times 1 plus 16, which gives 18 grams per mole. Carbon dioxide, CO2, is 12 plus 2 times 16, which is 44 grams per mole. And sodium chloride, NaCl, is 23 plus 35.5, giving 58.5 grams per mole. You should be able to calculate the molar mass of any compound quickly. Practice with a few from the periodic table. There are 3 key relationships you need to master. The first is how to find the number of moles. Moles equals mass divided by molar mass. So if you have 36 grams of water, and the molar mass of water is 18 grams per mole, then you have 36 divided by 18, which is 2 moles. The second relationship connects moles to the actual number of particles. The number of particles equals moles multiplied by Avogadro's number. So 2 moles of water contains 2 times 6.022 times 10 to the 23, which is about 1.2 times 10 to the 24 molecules. The third relationship is for gases at standard temperature and pressure. Volume equals moles times 22.4 liters. These 3 equations are the foundation of quantitative chemistry. Learn them by heart. Let us solve a typical NEET-style problem step by step. The question asks, how many molecules are in 36 grams of water? Step 1, find the molar mass. Water is H2O. So it is 2 times 1 for hydrogen plus 16 for oxygen, giving us 18 grams per mole. Step 2, find the number of moles. Moles equals mass divided by molar mass. That is 36 divided by 18, which equals 2 moles. Step 3, convert moles to molecules. Multiply moles by Avogadro's number. 2 times 6.022 times 10 to the 23 gives us 1.204 times 10 to the 24 molecules. That is our answer. Notice the approach: always find moles first, then convert to whatever the question asks. Moles is always the central step. This three-step process works for almost every mole problem you will see in NET. Here are your NET exam tips for the mole concept. The most common question type asks you to convert between mass, moles, and number of particles. Always read carefully to identify what you are given and what you need to find. For single elements, the molar mass in grams per mole equals the atomic mass from the periodic table. Oxygen is 16, carbon is 12, nitrogen is 14, and iron is 56. For the STP shortcut, remember that 22.4 liters is 1 mole of any gas. If a question gives you a volume of gas at STP, just divide by 22.4 to get moles. And the most common mistake students make, when you see O2 in a question, the molar mass is 32 grams per mole, not 16. 16 is for a single oxygen atom. Always check whether the question is asking about atoms or molecules. Excellent work! Let us review what you covered in this lesson. 1 mole always equals 6.022 times 10 to the 23 particles, and this number is called Avogadro's number. The molar mass of any substance is its molecular weight expressed in grams per mole. To find moles, divide the mass by the molar mass. To find the number of particles, multiply moles by Avogadro's number. And for gases at standard temperature and pressure, 1 mole always occupies 22.4 liters. In the next lesson, C002, we will build directly on this and learn about stoichiometry and limiting reagents, which is how we predict exactly how much product a chemical reaction will produce. That is where chemistry gets really powerful.